Okay, so we are starting with a new chapter here, that is Introduction to Trigonometry. According to your NCERT book, it is chapter 8. Okay, now we'll see what is trigonometry and some introduction to this today. You see, you have already studied about triangles. Of course you have studied, right? And in particulars, right triangles. You know what is right triangle? One angle should be equal to 90 degree in your earlier classes. Yes, you have done that. Okay, let us take some examples from our surrounding where right triangles can be imagined to be formed. I'll give you some examples. You see, suppose the students of a school. Okay. Suppose that the students of a school are visiting Qutub Minar. Now, if a student is looking at the top, suppose that this is the student here, this is the student here, and then this is the Qutub Minar. I'm just drawing simply. This is the Qutub Minar. Now, this is the distance from here. Now, suppose the students wants to measure student is looking at the top here. Okay, he or she is looking at the top of the minar here like this. Now, if the student is looking at the top of the minar, a right triangle can be imagined. Yes or no? You see here, it can be 90 degree here, 90 degree. Right triangle can be imagined here. Now, the question here is, can the student find the height of the minar without actually measuring it? Can this person find the height of the minar without actually measuring it? This is the question here. Yes, it can be. We'll learn how to find this type of using trigonometric identities. All this we'll learn in this chapter. Okay. Now, next I'll give you one more example. You see, suppose a girl is sitting on the balcony of her house located on the bank of a river. A girl, this is the house of the girl. Okay, this is the house. She is sitting on the balcony of the, this is the balcony. Suppose he is sitting on the balcony of the river, which is located balcony of the house, which is located on the bank of the river. This is the river, suppose. Okay, she is looking down at the flower. Suppose that here is a flower. She is looking down at this flower. This girl is looking down at this flower, a flower pot which is placed on a sphere of temple. Suppose that here is a temple. This is a temple. With this flower is located in the temple nearby on the other bank of the river. This is one bank, one side, and this is the flower is located on the other bank of the river. The girl house is located on the other side of the river, other bank of the river. Okay. A right triangle. Here also you see, a right triangle is imagined to be made in this situation. We can imagine that here is a right triangle. We can say that this angle here, we can say that this angle here is 90 degree. We can say that this angle is 90 degree. We can imagine that this is a right triangle. Okay. If you know the height at which the person is sitting, if you know that at which height this girl is sitting, we can find the width of the river. We can find this width of the river. Now you might be imagining now how it can be, but then I'll explain you. We'll learn all this in this chapter. Okay. Now again I'll give you some example. Okay. Suppose a hot air balloon is flying in the air. Suppose that this air balloon is flying on the air. A girl happens. Suppose that the girl is standing here. This is the girl. I'm just drawing it simply. Suppose the girl happens to spot the balloon in the sky, and she runs to tell her mother about it. Her mother rushes out of the house, but when her mother came out of the house, the balloon has reached here. Suppose the balloon has reached here. When the, okay, suppose that this is point A and this is point B. When both the mother and the daughter came out to see, it had already traveled to the point B. Yes or no? Now, just draw a distance here. This is the height. Again here, this is the first here. You see, this is the first when the daughter see the balloon was here. This was the height at that time. This was the height. I'll explain you later. Hypotenuse, we call this as hypotenuse. You might not know now. It might get confused. It's fine. I'll explain it later. Again, here also you see. Just think that here a right triangle has been formed. Here also a right triangle has been formed, isn't it? So, can you find the altitude of the B from the ground? Can you find the height of B from the ground? If you know this, the width, it's this type of question. Okay, we'll learn. Don't worry, I'll help you out. in all the situations given above, I gave you 3 situations, yes or no? Now, there, the distances or height can be found by using some special mathematical techniques. Okay. The distances and height can be found, which come under a branch of mathematics which we call it as trigonometry. Okay. We'll learn here. The word trigonometry is derived from the Greek word tri. Tri, meaning tree, and gon, meaning sides, and gon meaning sides, trigon, and then metron. Metron means measure. Okay, it's measure. Okay, fine. In fact, trigonometry is the study of relationships between the sides and angle of a triangle. Suppose this is a triangle, we learn the relationship. Suppose this is 90 degree, we learn the relationship between the angles and the sides, these sides and angles. We learn the relationship here. The earliest known work on trigonometry was recorded in Egypt and Babylon. Early astronomers used it to find out the distances of the stars and planets from the Earth. Even today, most of the technologically advanced methods used in engineering and physical sciences are based on trigonometrical concepts. You see here how many use do trigonometry have. So, in this chapter, we will study some ratio of the sides of a right triangle with respect to its acute angles. We shall use only acute angles here, called trigonometric ratios of the angle. However, these ratios can be extended to other angles also. Okay, we will also define the trigonometric ratio for angle of measure 0 degree to 90 degree. Also, we shall extend. I'll explain you where. We will calculate trigonometric ratios for some specific angles and establish some identities involving this ratio, which we call them as trigonometric identities. Just see the introduction portion now. It's called identities. I'll explain you. You'll get it's very easy only. Now you see here, what would I do is, I'll take a right triangle. I'm taking right triangle. I've taken this as 90 degree. This here is some angle here. This is A, this is B, and this is C. Okay. Now what would I do is, you see here, angle CAB, or just say angle A, is an acute angle. You see, you know the position of the side BC. The side BC with respect to angle A. BC faces angle A. You see here, BC faces angle A. We call it the side opposite to angle A. We can write here opposite. Okay. We call this BC as side ulta chha ni ta, opposite ma chha ni ta. So we call it as opposite. Opposite to angle A. Side opposite to angle A. And AC. What do we call AC here? AC we call it as hypotenuse. We call AC as hypotenuse. Okay. We call AC as hypotenuse. And side AB. What do we call AB then? AB we call side adjacent to A. We can call side adjacent to A, or we can call this as base also. Okay. This is called base also. Okay, fine. I hope you understood. Now, what will I do is, I will change the position of sides which we did earlier in the earlier triangle. I'm changing the position. A, B, C. It's the same triangle. I'm just changing the position of the angle here. You see angle. This is side opposite to angle C. Opposite. And this is the base or adjacent here. Base nama dekhin, adjacent. Anything. And this is our hypotenuse. When we change the position of angle, okay, angle C, before it was on the angle A, now I am putting it in the angle C. You have studied the concept of ratio. I hope you have studied the concept of ratio. It's simple only. Now, we now define certain ratio involving the sides of a right triangle and call them trigonometric ratios. Now, ratios as we have studied earlier. Now, in this particular portion we are going to learn trigonometric ratios. Okay. Here I have taken the triangle, right triangle in the first case, right? I'm drawing the same here. This is a right triangle. This should be equal to 90 degree. It should be a straight line. I'm saying that this is A, this is B, and this is C. This is A, B, C. Now this is our angle. If this is our angle, then this should be opposite. Right here, O. Opposite. This is our base or adjacent. And this is our hypotenuse. Okay. Now what would I do is, I'll take the trigonometric ratios of the angle A from here. The first one is sine of angle A. Sine of angle A should be side opposite to angle A divided by hypotenuse. That is, opposite by hypotenuse will give me sine of angle A. Opposite is BC here, and hypotenuse, what is the hypotenuse here? Hypotenuse is AC. AC, okay? And before for sine of angle A. Now we will do for cosine. Okay. Now for cosine, we'll take COSINE. Cosine of angle A will be, cosine means base by hypotenuse. Okay, means base or adjacent. Base नभएदेखि adjacent पनि हुन सक्छ, or base by hypotenuse, which would come out to be, my base is AB. AB by hypotenuse is AC. Okay. Now next let's do again here. Cosine को भयो. After cosine, I'll be taking here another identity. अर्को identity लिन्छु जुन चाहिँ हुन्छ tangent. Tangent of angle A will be, tangent चाहिँ के हुन्छ भन्दाखेरि नि, tangent would be opposite by adjacent. Opposite by, you need to by heart all this तिमीले सबै याद राख्नुपर्छ है. Opposite is what is opposite here? BC. What about adjacent? Adjacent नभएदेखि base. What is it? AB. Okay. Now next, after tangent we'll learn cosecant. After tangent, what we will learn is cosecant. I'm writing here COSECANT. Cosecant of angle A will be hypotenuse by opposite. What it would be? Hypotenuse by opposite. Say with me, hypotenuse by opposite. Cosecant of angle A. Cosecant of angle A would be hypotenuse by opposite, which is, what is my hypotenuse here? AC. What is my opposite here? BC. AC by BC. Okay. Now after this I have again, after cosecant I'm taking only secant. Only secant would be there. For secant I'll be taking hypotenuse by adjacent. Say with me, hypotenuse by adjacent. Hypotenuse by adjacent, which is hypotenuse adjacent right here, A. What is my adjacent here? Adjacent नभएदेखि base, it is AB. AC by AB, second को. Now next we have last, this is the last one. के हो भन्दाखेरि चाहिँ, let me rough all together. What is it भन्दाखेरि चाहिँ नि, cotangent. Okay, हामीले tangent हेरेको थियो हैन, अहिले चाहिँ cotangent छ. Cotangent means cotangent of angle A would be equal to base by opposite. Okay, base by opposite. Base is, what is the base here? AB. Base here AB. Opposite is BC. AB by BC. Base by opposite. Okay. यसमा अघि निकालेको जुन रेशियोज छ, जो अघि हामीले जुन निकाल्यौं साइन कोसहरुको, तिनीहरुलाई चाहिँ साइन एंगल ए, साइन ए, ओके, कोस ए, टेन ए, त्यसरी लेख्दा हुन्छ। कोसेक ए, सेक ए र कोट ए। नाउ यु सी हियर, मैले अघि के भनेर थिएँ, रेसिप्रोकल हुन्छ साइन र कोसेक, रेसिप्रोकल कोसेक र सेक, रेसिप्रोकल टेन र कोट रेसिप्रोकल। अब चाहिँ के छ भनेदेखि एउटा डिराइभेसन गर्छौं हामी यहाँबाट। एउटा डिराइभेसन गर्छौं के भन्दाखेरि अघि हामीले निकालेको थियो टेन के निकालेका थियौं अघि हामीले, टेन्जेन्ट, टेन अफ ए इक्वल टु के थियो, अपोजिट बाई एडजेसेन्ट। अपोजिट हामीहरुको बीसी थियो अघि, एडजेसेन्ट के थियो, एबी। यस और नो? अब हामीले यिनीहरुलाई बीसी लाई र एबी लाई दुईटै तर्फबाट एसी ले डिवाइड गर्यौं। हेर्नुस् है, मैले बीसी बाई एसी ले डिवाइड गरे अनि यहाँनेरि पनि एबी लाई एसी ले डिवाइड गरे। किन मैले यसो गर्न सक्छु भन्दाखेरि चाहिँ बिकज यो एसी र एसी काटिन्छ नि त, काटिएपछि त एउटै रहन्छ, फेरि बीसी बाई एसी नि रहन्छ, बीसी बाई एबी नि रहन्छ, हामीहरुको सेमै आउँछ। सो यसले केही फरक पर्दैन। सो आइ एम इन्सर्टिङ एसी हियर अन द बोथ साइड। दुईटै तर्फबाट डिवाइड गर्दैछु। Now after this, हेर्नुस् अब यहाँबाट यो गरिसकेपछि बीसी बाई एसी, अघिको ट्रिगोनोमेट्रिक रेशियो जुन हामीले निकालेको थियो, बीसी बाई एसी के को थियो, थिङ साइन को थियो, साइन अफ एंगल ए। ओके, एबी बाई बीसी के को थियो, आई मिन एबी बाई एसी के को थियो, कोस को थियो। त्यसो गर्दा हामीले यहाँबाट के कन्क्लुजन पायौं भन्दाखेरि चाहिँ हेर्नुस् है, यो त साइन ए बाई कोस ए भयो। हामीले यहाँबाट के कन्क्लुजन पायौं भन्दाखेरि tan of angle A will be equal to sine of angle A by के, sine of angle A by cos of angle A। अब यो गरेपछि हामीलाई याद छ कि tan र cot त रेसिप्रोकल हुन्छ, रेसिप्रोकल उल्टा पुल्टा हुन्छ। अब tan को जग्गा मैले cot of A लेखे भने, कोटेन्जेन्ट लेखे भनेदेखि कोटेन्जेन्ट के हुन्छ, यसकै रेसिप्रोकल cos A by sin A, इसके reciprocal यति। Okay, understand what we did here now. Now you see the trigonometric ratios of an acute angle in a right triangle express the relationship between the angle and the length. Angle र length को बीचमा relationship बुझाउँछ त्यो trigonometric ratios ले, हैन? त्यो हामीले पढ्यौं। अब हेर्नुस्, हामीले जुन अघि सिम्बल sin A युज गरेको छ, is used as an abbreviation को लागि मात्रै sin of angle A भनेर युज गरेको, तर it's not that sin of angle A युज गरेको थियो। यो चाहिँ बस एब्रिभिएसन को हिसाबले युज गरेको हो। यसलाई प्रोडक्ट, यसको बीचमा प्रोडक्ट छ भनेर युज गरेको हैन। that you should remember that cos A is not the product of cos A. Similar interpretation follow for other trigonometric ratios also. अब हेर्नुस्, now if we take a point P on the hypotenuse AC, let's do this, okay? Now what will I do is take a triangle again, right triangle. This is 90 degree. This is A. Let's see, take here. This is A. You say 90 degree. You BO. And this is C. Now you see, if we take a point on the point P of point P on the hypotenuse AC. Suppose हामीले यो hypotenuse मा यहाँनेरि point P लियौँ अरे हैन, and a point Q on AC extended भएर जाँदाखेरि चाहिँ यहाँनेरि हामीले point Q लियौँ अरे। त्यहाँबाट के भन्दैछ, and draw of the right triangle ABC and draw PM perpendicular to AB. त्यहाँबाट मैले PM लाई चाहिँ AB को perpendicular मा ड्राइङ गरे, PM perpendicular to AB and QN perpendicular to AB extended, QN perpendicular to AB extend भएको छ नि त, त्यहीबाट AB extended. Now will the trigonometric ratio of angle A in PAM differ from those of angle A in CAM or from angle A in QAN? Now के भन्दैछ भनेदेखि trigonometric ratio, यहाँ हेर्नुस्, trigonometric ratio of angle A चाहिँ यो PAM भन्ने ट्रायंगलमा डिफर गर्छ के CAB मा डिफर गर्छ ट्रिगोनोमेट्रिक रेशियो, नभएदेखि एंगल A र QAN मा डिफर गर्छ। हेर्नुस्, मैले अहिले भर्खर एउटा ट्रायंगल ड्राइङ गरेर तपाईहरुलाई देखाएको थिएँ कि तिनीहरुको रेशियोजहरु डिफर गर्छ भनेर हैन। यो क्वेशन आन्सर गर्नको लागि तपाईहरुले च्याप्टर 6 मा त्यो सिमिल्यारिटीहरु पढ्नु भएको छ, अफ कोर्स राइट, त्यो पढ्नु भएको छ। त्यो यो क्राइटेरियन युज गरेर चाहिँ हामीले अघिको ट्रायंगल PAM र CAB हरुलाई सिमिलर छ, प्रोपोर्शनल, तिनीहरुको करेस्पोन्डिङ साइड्स अफ द ट्रायंगल आर प्रोपोर्शनल, त्यसरी प्रुफ गर्न सक्छौं। नाउ लेट मी डू फर यु, म ट्रायंगल फेरि ड्राइङ गर्दैछु। यो चाहिँ Q अरे, त यो चाहिँ C अरे, यो चाहिँ P अरे, यो चाहिँ A, P बाट M परपेंडिकुलर, यो B चाहिँ 90 डिग्री छ, यसबाट N परपेंडिकुलर। अब हामीले अगर हेर्नुस् यहाँनेरि, अगर PAM र CAB चाहिँ सिमिलर छ भनेदेखि के हुन्छ, यो त तपाईहरुलाई यादै हुनुपर्ने, AM बाइ सिमिल्यारिटी को त्यो च्याप्टर 6 मा पढेको थियो नि, AM बाइ AB हुन्छ। ओके, यसको चाहिँ AM बाइ AB हुन्छ। अनि हामीले अर्को ट्रायंगलको लिँदाखेरि चाहिँ एउटा साइडको चाहिँ यो ट्रायंगलको यो AM चाहिँ प्रोपोर्शनल टु AB हुन्छ, रेशियो AB को इक्वल, त्यसरी लेख्न सकिन्छ। र यतापट्टि पनि यो हेर्नुस्, AP र AC लाई पनि त्यसरी लेख्न सकिन्छ, AP बाइ AC। अनि फेरि हेर्नुस्, हामीले यो छ नि, यो लाइन, यो हाइट जस्तो, यसलाई पनि त्यसरी लेख्न सकिन्छ, MP बाइ BC भनेर। ओके, अब हेर्नुस्, हामीले यहाँबाट के फाइन्ड गर्यौं भन्दाखेरि MP बाइ AP, MP बाइ AP चाहिँ, अब हेर्नुस् ल, म के गर्छु भन्दाखेरि नि, यो लिन्छु कि यति लिन्छु, यति लिएपछि यहाँबाट फाइन्ड गर्दैछु। एकछिन रोक्नुस्, कन्फ्युजन हुन्छ फेरि, रफ गरिहाल्छु। यो यसलाई चाहिँ हटाइदिए मैले, हेर्नुस्, यसलाई चाहिँ हटाइदिए। अब यो साइड मात्रै लिन्छु, ट्रायंगल पनि मेटाइदिन्छु, अहिले तपाईहरुले कपी गर्नुभयो होला। अब हेर्नुस्, मैले यो मात्रै लिँदैछु, यसबाट चाहिँ मैले यसो गर्न सक्छु नि हैन, MP को मुनिपट्टि AB लाई पठाइदिन्छु, BC लाई माथि ल्याउँछु। यो त यादै हुनुपर्ने तपाईहरुलाई हैन, MP बाइ AP इक्वल टु BC बाइ AC, यो त सिम्पल छ, यो गरे मैले। अब हेर्नुस्, BC बाइ AC अघिको ट्रायंगलमा फेरि हेर्नुस्, या A थियो या B थियो, यहाँनेरि माथि कति थियो, यहाँनेरि C थियो, C को यहाँनेरि परपेंडिकुलर थियो। अब यसमा हेर्नुस्, BC बाइ AC भनेको के हो, अगर यो A चाहिँ एंगल हो भनेदेखि यो BC त अपोजिट भयो, BC अपोजिट भयो, AC हाइपोटेन्युस भयो। अपोजिट बाइ हाइपोटेन्युस भनेको कुन प्रपर्टी हो भन्दाखेरि साइन को प्रपर्टी हो, साइन अफ एंगल A निकाल्यौं यहाँबाट, यस और नो। यो कपी गरिदिन राख्नुस्, म मेटाउँदै छु। अब हेर्नुस्, मैले अहिले भर्खर साइन को प्रपर्टी, साइन को त्यो रिलेसन तपाईहरुलाई देखाइदिए। अब हेर्नुस्, त्यही ट्रायंगलमा फेरि मैले अघि निकालेको थिएँ, AM बाइ AB इक्वल टु AP बाइ AC इक्वल टु MP बाइ BC। मैले यो निकालेको थिएँ अघि, yes or no? अब यहाँबाट म अब चाहिँ के गर्छु भन्दाखेरि नै एएम एपी, म यो एमपीलाई चाहिँ अहिले लिन्न हो, एमपीलाई चाहिँ लिन्न, एमपीलाई हटाइदिउँ। यिनीहरू दुईटाबाट हामी रिलेसन डिराइभ गर्ने कसरी भन्दाखेरि एएमको मुनिपट्टि के जान्छ, एपी र एबी माथि आउँछ क्रस मल्टिप्लिकेसन, एबी माथि आउँछ अनि एसी तलै रहन्छ। अब हेर्नुहोस् एबी बाई एसीलाई हेर्नुहोस्, अघिको ट्रायङ्गलमा फेरि ड्रइङ गर्दैछु। यहाँनिर ए थियो, यहाँनिर पी होइन, यहाँनिर बी, यहाँ सी, यहाँनिर राइट ट्रायङ्गल। अब यसमा हेर्नुहोस् एबी बाई एबी यो, एसी, एसी खोइ यो एसी, एसी के हो, हाइपोटेन्युज। नाउ यो सी तपाईँहरू हेर्नुहोस्, यहाँबाट एसी भनेको हाइपोटेन्युज हो, एबी भनेको बेस हो। अब हाइपोटेन्युज बाई बेस भनेर हामीले कुन चाहिँ एङ्गल, कुन चाहिँ ट्रिगोनोमेट्रिक रेसियो पढेका थियौँ भन्दाखेरि चाहिँ एबी बाई एसी इक्वल टु कोस अफ ए, यस और नो, हामीले कोस अफ ए पढेको थियौँ। यति बुझ्नुभयो? अगेन अघिको हामीहरूको जुन मैले रेसियो निकालेको थिएँ, के निकालेको थिएँ, एएम बाई एबी इक्वल टु एपी बाई एसी इक्वल टु एमपी बाई बिसी। ओके, यहाँबाट चाहिँ अब म कुन रेसियो लिँदैछु भन्दाखेरि चाहिँ एमपी बाई एएम। आई विल बी रिमुभिङ द मिडल पोर्सन। मिडलको रेसियोलाई चाहिँ नलिएर यो साइडको रेसियो लिँदैछु। यो साइडको रेसियो लिँदाखेरि के गर्छु भन्दाखेरि हेर्नुहोस्, अघिको जस्तै एएमको एमपी यता छ, एमपीको मुनि एएम आउँछ, क्रस मल्टिप्लिकेसन यो र यो एमपी चाहिँ यसको मुनि जान्छ, बिसी चाहिँ माथि आउँछ, बिसी माथि आएपछि बिसी बाई एबी आयो। अब हेर्नुहोस् फेरि अब अघिको ट्रायङ्गल म फेरि ड्रइङ गर्दैछु कन्फ्युजन हुन्छ भनेर। हेर्नुहोस् यो थियो अघिको ट्रायङ्गल, यस्तो थियो, यहाँ ए थियो होइन, यहाँ बी थियो, यहाँ सी थियो, यहाँ ट्रायङ्गल राइट यो एङ्गल भयो। अब बिसी भन्दैछु, बिसी भनेको के हो, अपोजिट, एबी भनेको के हो, बेस। अपोजिट बा बेस भनेर कस्तो रिलेसन पढेको थियो हामीले अघि, हिजो होइन अघि नै हो, बिसी बाई एबी इक्वल टु टेन अफ ए टेन्जेन्ट, यो पढेको थियो। यसले चाहिँ हामीलाई के देखाउँछ भन्दाखेरि चाहिँ ट्रिगोनोमेट्रिक रेसियो अफ एङ्गल ए इन पिएएम, अघिको पिएएम र डु नट डिफर फ्रम दोज इन सिएबी, मतलब के डिफर हुँदो रहेन भनेर देखाउँछ। इन द सेम वे यु सुड चेक द भ्याल्यु अफ साइन ए रिमेन द सेम इन। अब हामीले त्यस्तै गरेर अर्को एक्सटेन्ड गरेको थियो नि, यहाँ क्यु थियो, यहाँनिर क्यु थियो, यहाँनिर पी ल्याएको थियौँ होइन, यिनीहरू अलग अलग हुँदो रहेन, सेमै हुँदो रहेछ भनेर यहाँबाट कन्क्लुजन पायौँ। From our observation, it is now clear that the values of trigonometric ratio of an angle do not vary with the length of the side of the triangle if the angle remains the same. अगर एङ्गल चाहिँ सेम छ भनेदेखि लेन्थ अफ द साइडमा भेरी गर्दैन भनेर हामीले यहाँबाट चाल पायौँ। ओके, now you see here, for the sake of convenience we may write, see here, we can write sine square a, cos square a, etc. We can write this. Okay, in place of, we can write in place of sine a whole bracket को square sine cos a whole bracket को square. In place of this we can write this. There's not any problem. Okay, but there is one thing here. But you see, we know that sine a equal to 1 by cosec, yes or no, cosec a. We know this. Now can I write cosec, अब मैले यसरी लेख्दा हुन्छ त, cosec of a चाहिँ equal to sine of a को inverse. Can I write like this? Yes, I can write like this. यसरी लेख्दा हुन्छ. But हेर्नुस्, I can write in this way, but then I cannot write in this way. You should remember this, that I cannot write cosec of angle A will be sine inverse A. I cannot write. It is called sine inverse A. Sine inverse A has a different meaning. This particular word is different meaning, which you will learn in higher classes. Now, for now, don't use this symbol. Use which I gave you. This one. In a similar convention, hold for the other trigonometric ratio as well. Sometimes the Greek letter theta may also be used to represent the angle. Okay, we have defined 6 trigonometric ratio of an acute angle. Now you see, if I'll tell you, if we know any one side, any one ratio among the 6, can we find the other? Yes, of course we can find. I'll help you out with this. I'll draw a triangle. I'm drawing a triangle here. This is A, this is B, and this is C. This is a right triangle, 90 degree. Here is the angle. Now, if I know any one of the trigonometric ratios, suppose I know that sine of angle AJ 1 by 3 हो भनेदेखि, can I find the other ratio? Yes, of course I can. From here you see, what is sine? Sine भनेको के हो? Opposite by hypotenuse. Opposite by hypotenuse. Yes or no? It's nothing but opposite by hypotenuse. Now you see here, what is my opposite here? Opposite is BC. BC by hypotenuse is AC. Yes or no? We have our 85. BC by AC. I got from here BC by AC. I'm rubbing out this. I got from here that BC by AC is 1 by 3 because यो चाहिँ BC by AC भयो नि त. त्यसो गर्दाखेरि मैले BC चाहिँ 1 पाएँ, AC चाहिँ AB चाहिँ 3 पाएँ. Now from here the length okay, if BC is equal to K, then AC will be 3K. अगर BC चाहिँ के हो भनेदेखि just 1K लेखिदिराखौँ न. त्यसो गर्दाखेरि यो चाहिँ 3K हुन्छ. Let me use another pencil. यो 3K हुन्छ. यो 1K, यो 1 हो. 1K भयो. Now where K चाहिँ एउटा just positive number मात्रै हो. Don't get confused with it. To determine other trigonometric ratio for the angle A, we need to find the length of the third side. हामीले यो third side AC को length find गर्नुपर्छ. AC को length find गर्नको लागि तिमीहरूलाई Pythagoras theorem याद छ होला. Pythagoras theorem ले के भन्छ? हामी AC निकाल्छौं. हामीले AB र BC त पायौं. So I'm using the Pythagoras theorem now to find AC. What does the Pythagoras theorem says? Hypotenuse equal to base को square. Hypotenuse को square equal to base को square plus यो height को square. अब AC हामीलाई याद छैन. AC नै रहोस्. AB याद छ हामीलाई. AB हो 3K. 3K को square plus BC याद छ. K को square हुन्छ. अब AC will be equal to 3 are 9. 9K को square plus K को square. AC आयो 10K square. Okay. Over. No, I've done a great mistake here. I'm sorry for that. Yeah, हेर्नुस्. मैले यहाँनेरि base लाई चाहिँ 3K लेको रहेछु. This should be 3K. Sine the opposite by hypotenuse हो नि त. So this should be 3K. If this is 3K, then I need to find AB. मैले AB निकाल्नु पर्छ. To find AB, यो AB चाहिँ छैन. Okay. AB चाहिँ छैन. AC is given 3K. AB चाहिँ छैन. Okay. AB चाहिँ छैन. AC is given 3K. Now to find AB, I'll use the Pythagoras theorem. Pythagoras theorem बाट हेर्नुस्. What is there is AC square equal to AB square plus BC square हुन्छ. You can see here I'm rubbing out this. It's little inconvenient, but then see, just now we drew a triangle. OMG, what is this? Just now we drew a triangle. Say this was the triangle. This is our 90 degree, A, B and C. I say that sine of angle A is 1 by 3. From 1 by 3 I knew that BC is 1 and then AC is 3 because opposite by hypotenuse. Now this is K, this is also K. Okay, now you see here, what did I did was I was taking the Pythagoras theorem. From Pythagoras theorem in triangle ABC, I know that AC square is AB square plus AB square plus BC square over AC. We don't know AB, so AB line I'll bring one side and then I will take AC, the known values on the other side, AC by BC. Now you see here, AB we don't know, just put AB square. AC I know that is 3K cos square minus BC I know K cos square. Okay, you see here 3 are 9, 9K square minus K square will give me, what would it give me? 8K square. Let me write it above. Let me write this first. This is 3K and this is A. Okay, now you see here I'm using again. Now what would I do is I knew that AB square equal to 8K whole square, or then no whole square, just square only. This whole is not needed here. Whole is not needed here. So from here, you know that 8 भनेको के हो? You know that 8 means AB square 8 भनेको, you see, if I write 2 root 2 K whole square. Did you understand? I'll explain with. Let me first rough this. You see here 2 are इसको स्क्वायर निकालिदिनुस् 2 are 4 2 are 4 हुन्छ यहाँबाट त्यहाँबाट रुट 2 को स्क्वायर निकालेपछि यो र यो रुट काटिन्छ k स्क्वायर रहन्छ 4 2 are 8k. I can write 8k in this form. Okay, यो याद राख्नुस्. I can write 8k in this form. So after this what would I do is म अब AB यो स्क्वायर छ स्क्वायरलाई उतापट्टि पठाइदिएपछि यस्तो हुन्छ नि स्क्वायर को उतापट्टि गएपछि रुटमा आउँछ यो के हुन्छ भने नि यो स्क्वायरलाई काटिदिए मैले सपोज स्क्वायरलाई काटेपछि यतापट्टि पुगेपछि रुटमा जान्छ रुटमा गएपछि रुट र यो स्क्वायरलाई काटिदिए मैले सपोज स्क्वायरलाई काटेपछि यतापट्टि पुगेपछि रुटमा जान्छ रुटमा गएपछि रुट र यो स्क्वायर काटिन्छ रुट र स्क्वायर काटेपछि मसँग बस 2 root 2 k मात्रै बाँच्छ यो प्लस माइनस त रहन्छै रहन्छ. नाउ अब हामीहरुको AC चाहिँ माइनस हुन सक्दैन सो हामीले माइनस लिन्न प्लस मात्रै लिन्छौं. ओके AC भनेको AB चाहिँ माइनस हुन सक्दैन सो AB चाहिँ प्लस लिन्छौं जुन चाहिँ लिन्छौं कति भने देखिन 2 root 2 k आयो. नाउ आफ्टर नोइङ दिस वी क्यान फाइन्ड ऑल द रेशियोज. ओके अब ऑल द रेशियोज कसरी फाइन्ड गर्ने I'll teach you. Now you see just before I drew a triangle. I drew a triangle. This is A, this was A, this was B and this was C. I knew that AC was 3K and then BC was K. Now I find out by Pythagoras theorem that AB was 2 root 2 K. Now by this we can find anything from here. Let's try with cos of A. If I want to find cos of A भनेको के हो? Adjacent by hypotenuse. What is my adjacent here? AB. AB by hypotenuse is AC. What is my AB here? 2 root 2k. What about AC? What is AC? 3k. K and k will gone. So my cos of A will be 2 root 2 by 3 is the answer. Similarly, we can find any other thing from here. Okay. Trigonometric ratios of some specific angles. This is our topic. I'm expecting that from geometry you are familiar with the construction of angles of 30 degree, 45 degree, 60 degree, 90 degree and also 0 degree. Okay. Now we will find the values of trigonometric ratio for these angles. Okay, today. Now firstly we'll do trigonometric ratios of 45 degree. To do this, I'm taking a triangle. I'm taking a triangle ABC. It should be a right triangle. This is my A, this is my B and this is my C. Now B is 90 degree here. A is some angle here. In right triangle ABC, right angle is at B. Okay. If one angle is 45 degree, if I say that angle A is 45 degree, then the other angle is also 45 degree, because in a triangle all the sides should be equal to 90 degree. 180 degree. Now we know here that B is 90 degree, then these two should contribute to 90 degree. If one is 45, then the other should be also 45. This is also 45. Okay. Now you know till here. You can write your angle A equal to angle C equal to 45 degree. Now we are so because of this, BC will be equal to AB. Okay, BC will be equal to AB. Suppose that BC and AB will be equal to A. Suppose that this is A. Okay. Now you see here, if I take the Pythagoras theorem, by Pythagoras theorem in triangle ABC, AC square will be equal to AB square plus BC square. Yes or no? We know this. Now you see what is my AB. AB is A square. BC is also A. So A square. Together I got 2A square. You can write here somewhere 2A square. What did I got? 2A square. Yes or no? I got 2A square. So from here, what would I do is, now you see, just now we found out that AC square equal to 2A square. Yes or no? I found out this. Now if I take the square on the right hand side, I'll get here 2A square. The square and square will be gone, so I'll get A root 2. Okay. Now I got AC. After finding AC, what would you do is take the pencil again. This was my triangle before. I took this as A, this is B and this is C. I assume that AB is A and BC is A. Just now I found out that AC is A root 2. Yes or no? I found out that AC is A root 2. Now start finding the ratio of trigonometric ratios from the definition. Now we'll find the ratios. Okay, I took the triangle just before here. This was A, this was my B, this was 90 degree, this was 45, this is also 45, this was C and this was A, this was A. AC was A root 2. I found out just now A root 2. Now we'll find the sine 45. Let me change my color here. We'll find sine of 45 degree because we are finding the trigonometric ratios of 45 degree. Yes or no? So what we do? So now you see sine 45 degree. Sine is the ratio of sine is opposite by hypotenuse. Opposite by hypotenuse. You see here opposite. If I take angle A को opposite BC हुन्छ, hypotenuse AC हुन्छ. So के हुन्छ भन्दाखेरि BC by AC. मेरो BC के हो हेर्नुहोस् A, AC के हो A root 2. Yes or no? A by A root 2 आयो. Now I'll tell you again. You see here. Now let me write this side. Okay, I'm writing this side. You see here, I can cut this out. A and A can be gone. So I got 1 by root 2. what did I get from here is sine 45 को value चाहिँ 1 by root 2 हुन्छ. Now in the same way we'll do for all the others also. Okay. I rough the triangle, yeah. Let me draw again. This was A, this was B, this was C, this was A, this was A, this was 90 degree, and then this was 45, 45, this was A root 2. Now we find the sine 45 degree just now. Now in the same way we'll do for cos 45 degree also. Cos 45 degree, you see here, cos 45 degree, cos भनेको के हो? Adjacent by hypotenuse. Adjacent means AB. AB is the adjacent here. Hypotenuse is AC here. Adjacent AB is A here. AB is AC. AB is A and AC is A root 2. A and A will be gone. My answer would come out to be 1 by root 2. Hence, like for sine 45 degree, cos 45 degree को value पनि 1 by root 2 हुन्छ. Cos 45 degree value also 1 by root 2 नै हुन्छ. Okay. You see, just now we find for cos 45 degree. Now I'll do for tan 45 degree quickly. Okay. Tan 45 degree, you see here. Tan को ratio हुन्छ opposite by adjacent. What is my opposite here? BC is opposite. Adjacent is AB. BC कति हो? BC हो मेरो A. AB पनि A हो. So A and A will be gone. Tan 45 degree को value 1. 1 is the value of tan 45 degree. Okay. Now after finding these three, you see here, we know that cosec 45 degree, cosec theta is reciprocal of sine theta. 1 by sine theta हुन्छ 1 by 45 degree. Sine 45 degree भनेको 1 by root 2 थियो. So sine 45 degree 1 by root 2 थियो. के हुन्छ यहाँनिर भन्दाखेरि नि यहाँ हेर्नुस्. Sine 45 degree 1 by root 2 थियो. So यो root 2 माथि आउँछ आन्सरमा. You see here, root 2 will come above. So cos 45 degree को value root 2 आयो. That is reciprocal of sine 45 degree. Cosec 45 degree, sine 45 degree को reciprocal. Again here, I have find for sine, cos, tan, cosec 45 degree. Now I'll do for sec 45 degree. You all know that sec चाहिँ के को reciprocal हुन्छ भन्दाखेरि cos को reciprocal हुन्छ. Cos 45 degree को reciprocal हुन्छ. अब मलाई याद छ कि cos 45 degree भनेको 1 by root 2 हो. अब यो root 2 माथि गएपछि के हुन्छ root 2. Now again we are left with only one ratio, that is cot of 45 degree. Now we know that cot is the reciprocal of tan. Tan 45 degree को reciprocal हुन्छ. अब हामीले याद छ कि tan 45 degree भनेको त कति हो 1 हो. So 1 by 1 त 1 आउँछ. So cot 45 degree पनि 1 नै आयो हाम्रो. Okay. Completed the trigonometric ratios of 45 degree. Now what we will do is trigonometric ratio of 30 degree, 60 degree, 0 degree, 90 degree. We are left with that. Firstly, we will go with 30 degree and 60 degree. Okay. You see here, I'll be drawing a triangle. Triangle. This is a triangle. Wait, let me do with black. This is a triangle here. A, name this is A, this is B, this is C. Okay. This, yeah. Okay, you see here I'm doing this. This is B. Now you see it. Let us now calculate the trigonometric ratio of 30 degree and 60 degree. Okay. Considering this is an equilateral triangle ABC, all sides are equal to 60 degree. You know that all the sides of the equilateral triangle are equal to 60 degree, right? Now what will I do is I will take a perpendicular here from AB, from A to the base BC. I will name this as D. Now this angle BAD will become 30 degree here. You know this, and 30 degree, this is 30 degree, and this is 60 degree, and this is also 60 degree. Okay, you know this. I'm rubbing out this. I was just showing you. You know this. I won't write this here. Okay, now here you see. Now after drawing the perpendicular, what would I do is, you see here, triangle ABD, triangle, let me change my ink, triangle AB, it can't be seen here again, you see, ABD is similar to triangle, similar congruence to triangle ACD. ABD, ACD are similar because angles are same. They are both 30 degree. The sides are same because of that. Okay. Now because it's an equilateral triangle. Now we also know since these two are similar, what will happen is, since these two are similar, you see here, I'm rubbing out this. Give me a second. Okay, since these two are similar, BD would be equal to DC. Okay, BD चाहिँ equal to DC हुन्छ. Now, therefore, from here again, angle BAD would be equal to angle CAD because these are similar. From the congruence theorem, if we prove also, it would be similar, obviously. Now, observe that triangle ABD is a right triangle, right angle at D. Okay, right angle at D, it's a right triangle. With BAD is 30 degree here and ABD is 60 degree here. Okay, now as you know, for finding trigonometric ratio, we need to know the length. So we'll find the length here first. We have known all the angles. We know that angle A here is 60 degree wholly, and angle BAD is 30 degree. Angle ABD is 60 degree. Angle ADB is 90 degree. We know all this. Now we'll find the sides. Okay. We shall be finding the sides of the triangle before. Okay. Where's my pencil? Here it is. You see, this was my triangle before. This was my triangle. This was 60 degree. This was also 60 degree. I drew a perpendicular here. I mean, this perpendicular is from perpendicular from here, AD. Right. This was my A. This was B, and this was C. And then this was 30 degree. This was 30 degree. We knew this. From here, you see. Well, we are going to find the sides here now. BD चाहिँ half of BC हुन्छ. Okay, half of BC हुन्छ, जुन चाहिँ हामीले BC लाई चाहिँ A भन्ने भने suppose, so half of BC A equal to A. We say this now. Just assume this now. BD equal to half of BC, which is equal to A. Okay, now you see. Now what we do, BD चाहिँ A हो है, BD चाहिँ A हो, half of BC. Now what we will do is, you see, AD को square will be equal to Pythagoras theorem. I'm directly doing, you might get confused. Let me do fully with AB square equal to के हुन्छ, Pythagoras theorem ABD मा लाउँदाखेरि DB square plus DB square plus DA square. Yes or no? DA square. So मैले यो DA लाई AD पनि भन्न सक्छु नि त. AD लाई यतापट्टि लगे भने चाहिँ मेरो AB will come this side, so I can write AB will come this side. So के हुन्छ भनेदेखि AD square equal to AB square minus BD square. Okay, यो हुन्छ. Did you agree with this? यो हुन्छ. अब let me rough the lower portion. You see here again. AB. What is my AB? AB चाहिँ मैले this I'm assuming that all the sides are 2A. Okay, all the sides are 2A and BD and DC are, BD चाहिँ A हो, DC पनि A हो, BC पुरै चाहिँ 2A. Okay, यता पनि 2A, यता पनि 2A. Now AB मेरो के हो, 2A. 2A को whole square हुन्छ यहाँनेरि, whole square र BD के हो, minus BD भनेको A हो, A को square. Yes or no? I'm finding AD find गर्दैछु नि त यहाँनेरि. अब 2A को square भनेको 4A square minus A square के हुन्छ, 3A square. Yes or no? Just write. Where shall I write? I'm writing here. That is 4A square minus यो कति हुन्छ अरे, 3A square हुन्छ. Okay, 3A square आयो. 3a square आएपछि 3a square भनेको AD को स्क्वायर आयो 3a square equal to AD AD को square now after this AD को square after this finding the sides okay we're finding the sides what did I do was I took a triangle I'm doing this again and again you must remember this okay this is A this is B this is C and this is D this is 60 degree this is 60 degree this is 30 this is 30 this is 90 degree here so I told that AB is 2A I told that AC was also 2A and then BC is 2A and BD here is A and DC is also A. Now our aim was to find AD. Before while we were finding AD by Pythagoras theorem, I got that AD square equal to 3A square. Yes or no? Now what will you do now is give the square on the right hand side. Giving the square on the right hand side, I'll get root over 3A square. Obviously root baniन्छ square र square गयो. So I'll get A root 3. AD को त्यहाँ मेरो A root 3. So I have found all the sides of this triangle. Now what we would do is we will find the ratios. Okay. Well, you see here I need to draw the triangle again here. Triangle A. This is B. This is C. Perpendicular here AD. I know AB is 2A. 2A, this is also 2A, this is A, this is A, and AD was A root 3. Just writing here A root over 3. Okay, A root 3. AD was A root 3. Now let's find sine of 30 degree. Come on. Sine of 30 degree. Sine भनेको के हो? Opposite by hypotenuse. Sine of 30 degree. 30 degree is here. This is the 30 degree here. Right. BAD is the 30 degree opposite 30 degree को opposite BD भयो BD by opposite by hypotenuse AB is the hypotenuse opposite BD के हो A हो AB के हो 2A हो A gone 1 by root 2 is sine root 2 होइन 2 मात्रै 1 by 2 is sine 30 degree okay so now next what we will do is cos 30 degree निकालौं sin 30 degree निकालेपछि cos 30 degree निकालौं cos 30 degree के हो cos भनेको adjacent by hypotenuse अब यो 30 degree नै हो adjacent के हो यसको adjacent के हुन्छ AD adjacent हुन्छ adjacent by hypotenuse के हुन्छ AB अब यसको adjacent कति छ A root 3 छ AD भनेको A root 3 हो कि निकालेको थियो AB कति छ 2A A gone कति आयो root 3 by 2 is cos 30 degree next अब next गर्ने next चाहिँ tan 30 degree after this tan 30 degree root 2 root 3 tan 30 degree tan 30 degree tan भनेको के हो opposite by adjacent opposite के हो BD adjacent के हो AD के को adjacent के को opposite यसको किनकि 30 degree को निकाल्दै छौं BAD को अब BD भनेको के हो A AD भनेको के हो AD भनेको के हो C A root 3 यो र यो गयो कति रह्यो 1 by root 3 is the value of tan 30 degree okay now again I'm drawing the triangle this was my A this was my B this was my C I drew a perpendicular from here AD this was 90 degree this was 60 this was 60 this was 30 this was 30 and this is 90 now AB was 2A AC was 2A BD was A DC was A AD was A root 3 now we have find sine 30 degree cos 30 degree tan 30 degree now we'll find for cosec start from cosec cosec 30 degree cosec 30 degree now see here cosec भनेको के हो sin को opposite हो sin 30 degree भनेको के हो opposite by hypotenuse थियो so यसको hypotenuse by opposite हुन्छ यसको hypotenuse के हो AB opposite के हो BD AB के हो 2A BD के हो A gone 2 आयो बुझ्यौ 2 directly मैले directly निकाल्दा पनि हुन्थ्यो यसरी निकाल्दा पनि हुन्छ I have done in this way it's better Now let me rub this. We'll do for cosec को बाद में sec. Sec 30 degree. I'm doing for sec 30 degree here. Sec 30 degree. Sec बनेको के हो? Sec बनेको opposite of reciprocal of cos 30 degree. Cos 30 degree अघि कति निकालेको थियो? √3/2. So यो कति हुन्छ? 2/√3. बुझ्यो होला? Next what we would do is इसको बादमा I will do cot 30 degree. Okay, where is my pencil here? Cot 30 degree. Cot भनेको के को रेसिप्रोकल हो? 10 को रेसिप्रोकल 1/10 30 degree. 10 30 degree भनेको कति थियो? 10 30 degree भनेको 1/√3 थियो. 1/√3 मतलब यसको चाहिँ √3 हुन्छ. Cot 30 degree equal to √3. Okay. We have find for 30 degree. For 30 degree, 45 degree. Now we'll take the same triangle as before and we'll find for what? 60 degree. This is A, this is B, this is C, perpendicular from here, AD. This is 90 degree, this is B, 60, 60, this is 30, this is 30. Okay, now this was 2A, this is also 2A, this is A, this is A, this is A√3. Now you see here, well, where we are finding for 60 degrees. So I'll take sine 60 degree. Take the 60 degree here. Where's the 60 degree? Here. This is my 60 degree. A, B, C. 60 degree from there. Opposite. What is the opposite of this? The opposite of this is AD. Opposite by hypotenuse. What is the hypotenuse? AB. Now you see AD is the hypotenuse. AD is opposite. AD को त्यो कति हो? A√3. AB कति हो? 2A. A and A जान्छ. यो √3/2 बच्चा. √3/2 is the value of sine 60 degree. Okay. अब sine 60 degree को बादमा we'll do for cos 60 degree. Cos 60 degree. Cos 60 degree भनेको के हो? Adjacent by hypotenuse. इसको adjacent के हुन्छ? यो angle को BC is the BD is the adjacent. Hypotenuse के हुन्छ? AB. AB hypotenuse, BD adjacent. अब BD के हो? A. Hypotenuse के हो? 2A. A gone. 1/2 is the answer of cos 60 degree. Okay. फेरि you see again. Now we would do for what? 10 60 degree. 10 भनेको के हो? Opposite by adjacent. Opposite के छ? AD is the opposite. You see here. AD को त्यो कति छ? Side A√3. AD opposite by adjacent. Adjacent कति हो? A. BD is the adjacent. A हो BD. So यो कति आयो? √3. यसको भ्यालु कति आयो? √3. अब यिनीहरुको निकालिसकेपछि हामीलाई सजिलै हुन्छ किनकि गरिहाल्छु. यिनीहरुको निकालिसकेपछि अब हामीले साइन को निकालिहाल्यौं. साइन को निकालेपछि कोसेक को निकाल्न त इट्स भेरी सिम्पल. यु सी हियर कोसेक 60 डिग्री भनेको त अपोजिट अफ साइन अफ 60 डिग्री. साइन अफ 60 डिग्री भनेको कति थियो? √3/2 थियो. सो यो 2/√3 हुन्छ. ओके. अब म सेक को निकाल्दै छु. सेक 60 डिग्री भनेको कोस को उल्टा हुन्छ. कोस 60 डिग्री भनेको 1/√2 थियो. हैन 1/2 थियो. सो यो 2 हुन्छ र 10 को निकाले मैले. 10 को बादमा कोट त 10 को उल्टा हो, रेसिप्रोकल हो. सो कोट यो चाहिँ मैले 10 को चाहिँ √3 निकालेको थिएँ. सो यसको चाहिँ 1/√3 हुन्छ. ओके. Ratios of 0 degree and 90 degree. Let us see what happens to the trigonometric ratio of angle A if it is made smaller and smaller in the right triangle ABC. Okay, what I'm trying to say is there is a triangle here. Triangle ABC. You see here. This is a certain angle. This is 90 degree. What will happen if we made this angle A smaller and smaller in this triangle? Okay, till it becomes 0. As angle A gets smaller and smaller, the length of side BC decreases. BC को length decrease हुन्छ. The point C gets closer to the point B, and finally when angle A becomes very close to 0 degree, BC को length घट्छ एंगल सी उदो आउन थाल्छ, तल आउन थाल्छ, आउन थालेपछि यसको एंगल ए को एंगल कति हुन्छ 0 हुन्छ बडे हैन. सो AC becomes almost the same as AB. त्यतिखेर AC र AB सेम हुन्छ किनकि ओभरल्यापिङ हुन्छ नि त. सो what त्यसो गर्दाखेरि हामीले अब 0 डिग्री र 90 डिग्री निकाल्दैछौँ. What is let me show you with this with figure. You see here. अहिले भर्खरको ट्रायंगल हामीहरुको यस्तो थियो अरे. ABC यस्तो थियो अरे. अब यो अलिकति घट्यो अरे, अलिकति यस्तो भएर अलिक सानो भयो अरे. यो अघि यहाँसम्म थियो, यो अलिक घट्यो, अहिले यहाँसम्म पुग्यो. अहिले ABC यहाँ पुग्यो. फेरि यो अलिकति यस्तो भयो अरे हैन. यस्तो भएर यहाँनेरि आइपुग्यो अरे. यहाँ आइपुगेपछि यो A भयो, यो B भयो, यो C भयो. अन्त यहाँनेरि आइपुगेपछि चाहिँ ओभरल्याप नै भयो अरे. A B यो C पनि यही माथिबाट थपियो अरे. थपियो अनि यो अघिको चाहिँ यस्तो थियो हैन. सो यसरी ओभरल्याप भयो भन्दाखेरि चाहिँ AC र AB को लेंथ सेम भयो. ओके. Just now अहिले भर्खरको ट्रायंगलमा this was triangle A, B and C. I told that यो तल जाँदाखेरि 0 डिग्री हुन्छ भनेको थिएँ मैले. When angle A is very close to 0 degree हैन, BC gets very close to O, BC gets very close to O, that is 0 degree, and so the value of sine A चाहिँ sine of A will be opposite by hypotenuse चाहिँ is very close to 0. Also angle A is very close to 0 degree. Okay, AC is nearly the same as AC चाहिँ nearly the same as AB, and so the value of cos A equal to adjacent भनेको AB by hypotenuse भनेको AC. किनकि AB र AC सेम हुन्छ तल आएपछि, सो यिनीहरु काटिएपछि 1 रहन्छ. त्यही भन्दैछ. यसले चाहिँ हामीलाई के गर्छ भन्दाखेरि नि, this helps us to see how we can define the values of sine A and cos A when A equal to 0 degree. We define sine 0 degree equal to 0, and then cos 0 degree would be equal to 1. Okay. Now you see what we will do is, just now I have shown you that sine of what? Sine of 0 degree चाहिँ 0 हुन्छ, and then cos of 0 degree is equal to 1. From here what we will do is, we know the relation that tan equal to tan any something, tan को चाहिँ we know the relation that tan theta equal to or tan 0 degree equal to sine 0 degree by cos 0 degree. Yes or no? Now I have found just now that sine 0 degree is 0, cos 0 degree is 1. Now 0 divided by 1 is 0, hence for tan 0 degree, sine 0 degree, cos 0 degree, we found the values here. Now after this, now you see here, I have found tan 0 degree equal to 0. Now cot 0 degree चाहिँ reciprocal of tan 0 degree. Now I know that 1 by tan 0 degree, I know that tan 0 degree is 1 by 0. You know that any number divided by 0 is undefined. You divide any number by 0, it would be undefined. Hence the value of cos 0 degree is undefined. Okay, remember this, it is undefined. Now next, sec 0 degree. Let's find for sec 0 degree. Sec 0 degree. Now I know that cos 0 degree, it's reciprocal of cos 0 degree. I know that cos 0 degree is 1, hence for this one reciprocal got a 1 out. And then cosec 0 degree, I know that sine 0 degree equal to 0, so 1 by sine 0 degree भनेको त sine 0 degree हुन्छ. So yeah, I'm writing here, you see here, I'm writing here 1 by sine 0 degree is 0, hence 1 divided by 0 is undefined, hence यसको पनि undefined भयो. Okay. See, before we did first case, now we'll do the second case. In this case, what we will do is, I'm taking a triangle here, triangle ABC. Now what will I do is, I will make this A greater, angle A लाई ठुलो बनाउनु, angle C लाई सानो बनाउनु. This is our task. Now let us see what happens to the trigonometric ratio of angle A when it is made larger and larger in triangle ABC till it becomes 90 degree. Okay, as angle A gets larger and larger, angle C gets smaller and smaller. Therefore, as in the case above, the length of the side AB goes on decreasing. The point A gets closer to point B. Your A चाहिँ यहाँनिर आउँछ अहिले. We'll see this A will come here. Finally, when angle A is very close to 90 degree, angle C becomes very close to 0 degree and the side AC almost coincides with the side BC. AC चाहिँ BC मा coincide गर्छ. See here, what does this mean? It would come like this. So you see here in this triangle, I अघि चाहिँ अलिक यता थियो. I have drawn little this side. अघिको चाहिँ यो point थियो हो. Before point was यो point थियो अघिको चाहिँ, यो चाहिँ अघिको हो, अहिलेको चाहिँ यो. This is A now, B now, C now. A अलिक यता आउँदैछ, A को एङ्गल बढ्दैछ. सो यसो गर्दै गर्दै यहाँनिर अझै उत्यो हुन्छ हो. अघि यतिको थियो, त्यहाँबाट फेरि A here, B here, C here, and then you see here. लास्टमा चाहिँ के हुन्छ भन्दाखेरि नि, लास्टमा चाहिँ त्यस्तो गर्दै गर्दै गएपछि ट्रायङ्गल एबी चाहिँ यसरी कोइन्साइड नै हुन्छ. ए यही हुन्छ, बी ए चाहिँ बीको कोइन्साइडमा बढ्छ र एङ्गल ए चाहिँ 90 डिग्री हुन्छ. ओके, र यो चाहिँ सी हो र एङ्गल सी चाहिँ कति हुन्छ? 0 डिग्री हुन्छ. दिस मच. ओके, see what we did just now, right? When angle C is very close to 0 degree, angle C चाहिँ close to 0 degree, and then angle A चाहिँ close to 90 degree. Okay, angle A चाहिँ close to 90 degree. Side AC is nearly the same as side BC. AC र BC त सेम जस्तो थियो, अघि कोइन्साइड भइरहेको थियो. So sine of A is very close to 1. यसमा चाहिँ sine of A चाहिँ close to 1. यतापट्टि 90 को छ नि त हैन. So it is close to 1. Also, when angle A is very close to 90 degree, अगर angle A चाहिँ very close to 90 degree, angle C is close to 0 degree. Angle C is close to 0 degree. Okay. Angle C is close to 0 degree र angle A चाहिँ sin of angle A चाहिँ कति? 1. Angle C 0 degree हुँदाखेरि the side AB is nearly 0, AB चाहिँ nearly 0, and so cos A is very close to 0. Before triangle, I'm talking about the triangle before which I drew just now. You see this was coinciding. यहाँनिर A थियो, B पनि यही थियो, C यहाँनिर थियो हैन. So यहाँनिर के भन्दैछ भने sin of A चाहिँ is close to 1, right? Also, when angle A is very close to 90 degree, angle A चाहिँ यहाँ 90 degree कै क्लोजमा छ नि त. So angle C चाहिँ 0 degree हुन्छ किनकि यो कोइन्साइड भइरहेको छ. And the side AB is nearly 0. यो side AB चाहिँ nearly 0. So cos A is very close to 90 degree. This much. Okay. Now from here what we will gain is, you see here, sine of 90 degree चाहिँ कति हुँदो रहेछ? 1, right? And cos of 90 degree चाहिँ कति हुँदो रहेछ? 0, किनकि यतापट्टि कोइन्साइड हुँदै थियो र एउटा चाहिँ बढ्दै थियो. Okay. Now after this, you just try to find the other trigonometric ratio of 90 degree. It's very simple only. It's very simple. So now what we will do is, after finding sine and cos, though it's very simple. Now, shall I give you a table? Okay, I'll make a table for you. Wait. You the table of the trigonometric ratios which we learned just now. You see here, sine of 0 degree is 0, sine of 30 degrees 1/2, 45 degree. Oh no, it's wrong here. You see, this should not be 45 degree. Okay, sine 45 degrees 1/√2. This is wrong here. It should be 1/√2, or it can be written √2/√2 is there, right? So if I divide both sides by √2, you see here, √2. If I divide √2/√2 here, I'll get mathi √2 huncha. So this would be correct. This would be correct. You see here. You decide this is one part. You see here. अब यो √2 को स्क्वायर भयो माथि हैन. अब तल 2 √2 भयो. हेर्नुस् है. √2 गन हुन्छ, जो जान्छ र तल 2 √2 यस्तो रहन्छ. 2 र 2 गएपछि यो 1/√2. So यसलाई हामीले √2/2 लेख्दा पनि हुन्छ. Okay, it's not any harm. It's the same. So you see here, sine 0 degree, all the values are given here. Tan, your cos, this is cos of 0 degree is not defined. This is not cos, what is this? Cot. Sine, cos, tan, sec, cosec, this should be cosec, okay. Cosec 0 degree is not defined. And then you see here, cot 0 degree is not defined. Similarly, others also. You try to remember this table, it's very important. And then you see here, you can observe that angle A decreases from 0 degree to 90 degree. 0 degree देखिए 9 degree मा 0 to 1 it decreases in हैन, 0 to 1 मा 0 to 90 मा decrease हुँदैछ. इलस sin A चाहिँ increases from 0 to 1. You see here sin A increases from 0 to 1, and then from cos A चाहिँ decreases. You see here cos A चाहिँ decreases from 1 to 0. Decrease हुँदैछ, sin increase हुँदैछ. You just remember this. It's nothing that difficult here, okay? Is deleted from the syllabus. So today we'll start with trigonometric. Now we'll start with trigonometric identities. Now you know that an equation is called an identity when it is true for all the values of the variable involved. Identity कब आउँछ भन्दाखेरि चाहिँ when it is true for all the variables involved. Similarly, an equation involving trigonometric ratios of an angle is called a trigonometric identity. An equation involving trigonometric ratios of an angle is called, all the trigonometric ratios of an angle is called trigonometric identity if it is true for all values of the angle involved. Remember this, okay? Now in this section we will prove one trigonometric identity, okay? We'll prove one trigonometric identity and use it further to prove other useful trigonometric identities. Now to do this, what I will do is, you see here I'm taking a triangle. I'm taking a triangle here, A, B, C. Okay, I'm taking triangle ABC. This is 90 degree. This is certain angle here. In triangle ABC, right angle is at B. So by Pythagoras theorem, we know that AC square equal to AB square plus BC square. We know this. Now dividing each term by AC square. Now if we divide everything by AC square, let me take another. Okay, I'm dividing everything by AC square. This also AC square. Divide this also AB also by AC square. Divide by AC square. And let me rough this triangle for now, okay? Let me rough this above also. I hope you understood this. This is very simple. It's Pythagoras theorem only. Now again, what I'm doing here is, you see here, I'm using my pencil, plus what was there? AC plus AB, BC was there, right? BC square by AC square. Now after this yo janja, yes or no? This would be gone. AB by AC, you can write this as AB by AC whole square, right? Plus BC by AC whole square equal to 1. 1 I took from this one, okay? You see here, I took 1 from here. 1 is, I wrote this one on the left, right hand side, and this on the left hand side. This one on the here, left hand side. Now I'm rubbing out this again. See here, what will I get from here? Now after doing this, you'll get one identity here. My triangle was this. This was my A, this was my B, this was my C, right? This was my 90 degree, certain angle is here. Now AB is here. AB is here, AB by AC. I'm looking here, you see AB by AC. AB by AC, AC is this. AB is AB by AC. Which trigonometric identity is this, you see? LI angle manera chai, which trigonometric identity is this? Adjacent by hypotenuse. Maneko cos of A whole square. Yes or no? Now you see BC by AC again. BC is this one, AC. This is opposite and this is hypotenuse. Opposite by hypotenuse maneko sine of A whole square equal to 1. From here I got one relation, that is sine of angle A square plus cos of square A equal to 1. I got this relation from here. Just now we find out the relation that cos square A plus sine square A equal to 1. Yes or no? Now This is true for all a such that a can be less than or equal to 90 degree, greater than or equal to 0 degree. Okay, it lies between 0 and 90 degree. A lies between 0 and 90 degree. So this is a trigonometric identity. Now, if let us divide 1, that is before the relation which we got from the triangle. Before we drew a triangle, I hope you remember, this was a right triangle, this was A, this was B, and this was C. Right. Now this was a certain angle, ABC. Okay, now you see here, from here we got that AC square equal to hypotenuse square equal to by Pythagoras theorem AB square plus BC square. Now if I divide all the sides by AB square, dividing all the sides by AB square dividing by AB square, divide this also by AB square, this also by AB square. Okay, now what will happen is, see here, what will happen is AC by AB, you can write AC by AB whole square, yes or no, equal to, I can write like this. Now this would, you write with 1 will be left, plus BC by AB whole square. Okay, now you see here, AC by AB, AC चाहिए, AC is this, AB is this, adjacent by hypotenuse, AC by AB, adjacent by hypotenuse, which, AC hypotenuse by adjacent, AC hypotenuse, AB is adjacent. Which trigonometric ratio is this? Can you guess? It's sec. Okay, sec square. A. Hypotenuse by adjacent, as we have learned before. Plus 1 plus BC by AB. BC by AB is opposite by adjacent, which is 10. 10 square A. From here, we got this trigonometric identity. This is our second trigonometric identity. Okay, you see here, just now I took find the relation, one identity, that 1 plus 10 square A equal to sec square A. You see here, this equation is true for A equal to 90, but it is not true for A equal to 0. It is true for A equal to 0, sorry, but it is not true for A equal to 90. Why it is not true? Because 10A and sec A are not defined for A equal to 90 degree. Okay, so it is not true. Hence the value of A will range from less than 90, greater than or equal to 0. Equal to ya hundaina. Okay, now next is draw the triangle again. It was here, this was our A, this was our B, this was our C. Now by Pythagoras theorem, you know that AC square equal to AB square plus BC square. Now what we will do is dividing all sides by BC. Dividing all sides by BC will give me AC by BC whole square here. Here AB by BC whole square, yes or no? And then BC by BC will give me BC square. Divide the BC by BC will give me 1 here. Okay, now what will I do is, like before, it's very simple. You see here, let me change mine. Now you see here, AC by BC. AC, this is AC. AC means hypotenuse, this is 90 degree. BC is this, hypotenuse by BC. Which trigonometric identity is this? AC by BC. It is cosec. Okay, hypotenuse by opposite. So it is cosec square A cosec को identity हो and AB by BC को एक identity हो. AB means adjacent by BC. Adjacent by opposite is cot. Okay, cot square A plus 1 is remaining here, 1. Now this is our third trigonometric identity. Okay, now you see here that this cosec A and cot A are not defined for A equal to 0, as we have learned before in the identity, yes or no? So what will happen is their value will range between A will range between what? Less than or equal to 90, equal to will lie here, greater than 0 यानी equal to हुँदैन. Okay, it should be greater than 0 only, it cannot be equal to 0. Now using these identities we can express each trigonometric ratio in terms of other trigonometric ratios. That is, if any one of the ratios is known, we can also determine the values of other trigonometric ratios. Okay.